Now, the next step for C.3 is wave phenomena. We'll start with looking at reflection, refraction, diffraction, as well as Snell's law. So, you should know these terms, wavefronts and rays. Both are imaginary lines. Wavefronts are imaginary lines that show points of a wave that are in phase, which means that each wavefront must be each line in wavefront must be separated equally, and the distance between each wavefront line is equal to the wavelength. Then you have rays, which are imaginary lines that show the direction of the wave propagation. And on wavefront diagrams, you can see here, this is the ray and these are the wavefronts. Rays are always perpendicular to the wavefronts and vice versa. They're marked by an arrow to indicate the direction as well. And you should note that each ray represents a single wave. This is a single wave pulse, I guess. Whereas wavefronts just merely indicate the different points at waves of the same phase. Then you have reflection, refraction, transmission, and diffraction. Reflection is when a wave hits and bounces off the boundary between two media, and as you recall, media can just be any form of particles, it can be air, water, so on and so forth. And in reflection, the angle of incidence is always equal to the angle of reflection, which is, it can be written as theta 1 equals theta 2. You can see here, this is what reflection is, and the angle is here. The angle is between the ray and the normal to the, that is perpendicular to the imaginary line that's perpendicular to the medium. As you can see here, the angles here are equal. Refraction is when a wave experiences a change in direction due to moving from one medium to another at an angle from the normal, as you can see here. And this change in direction is caused by the two media having different densities, which means that they would slow down the wave more or less, and that's what causes the change in direction. You should know that the higher the more dense the medium is, the lower the angle is going to be. The angle of refraction is going to be here, and then as you can see, it passes through again. Transmission in general is just the process of a wave moving through boundaries across several media. So you can see this is an example of transmission and refraction through refraction, whereas this is direct transmission. As you can see, there's no angle at which of incidence. The angle of incidence is 90 degrees, which means that it just passes straight through. And then you have diffraction. It's slightly different compared to these. Diffraction is when a wave arrives at a barrier or opening of limited width, and they have to, in order to pass through, the waves have to bend and spread out across different directions. So once they exit the boundary, you can see here that they go across wider directions. And you can see here, the smaller that you make the gap, the more spread out the waves are going to become. Now, to learn about Snell's law, which has everything to do with refraction, you have the value n, which is the refractive index. It's simply the ratio between the speed of light. Well, it's a measure of how much a medium can slow down light waves, which is why it's written as c over v, where v is the velocity of the light in the new medium. Because as you remember, c is equal to speed of light in a vacuum, which means that there's no medium. But because of the medium, because of there being more particles, it will slow down slightly. And that's just, n is the ratio of those two values. And theta, as mentioned, is the angle between the normal and the ray for each medium, and the normal is the imaginary line perpendicular to the boundary between two media. So this is the normal here, for example. And theta 1 is angle of incidence, theta 2 is the angle of refraction. You have, and v is just the velocity of the wave in each media. You have a concept called the critical angle, expressed as theta c, where if it's the angle of incidence at which incident light refracts along the boundary between the two media, which just means that the angle of refraction is 90 degrees, as you see here. If the angle of incidence is any bit greater than the critical angle, then what happens is total internal reflection, which means that it doesn't transfer into the new medium, it just reflects back in the same medium. Total internal reflection can only occur when there's a medium with greater refractive index. It's traveling from a medium with greater refractive index into one with less. Say if it was traveling from air to glass instead of glass to air, total internal reflection would be impossible. And then you have the formula for Snell's law, which is that the ratio of the two refractive indices of the media is equal to the ratio of their the angle of incidence and the angle of refraction and the angle of incidence. Be careful with that. It's not always 1 is the numerator and 2 is the denominator. It's the other way around here. For the sine theta, it's theta 2 is at the top and theta 1 is at the bottom. Or it's equal to the velocity of in the second medium divided by the velocity in the first medium. This can also be expressed, typically is expressed as n2 sine theta equals n1 sine theta. And yeah, that's Snell's law, and that's all you need to know for about that. The next step is to learn, keep in mind diffraction, because that's going to be relevant for the next bit, which is superpositions and Young's double slit interference pattern.